This is the big wave. Awesome. All right, good morning. Welcome, everybody, to Shiny Let's Be Bad Guys, exploiting and mitigating the top 10 web app vulnerabilities. My name is Mike Pirnat, and I just nailed my mic. Hi, Mike Pirnat. My friend here, Dave Stanek.
Hello, everybody.
Oh, do you want the mic, Dave?
Hello, everybody.
We work at American Greetings in Cleveland, Ohio, and one of the things that we do is we're responsible for training our developers about PCI and security issues. So hopefully y'all get to enjoy some of that as well today. Before we get started, we've got a few announcements that we've been asked to make. And while we're doing announcements, Dave's going to run by with the handout for today. So first thing is schedule and lunch. You're really going to care about lunch. So this session is going to run from 9 to 12:20 today. We're going to take a 20-minute break about 10:50. Lunch then is from 12:20 to 1:20. And the most important thing about lunch is to remember that it's been moved to Exhibit Hall D. It's not where any of the written materials say it is. They didn't have time to fix that, apparently. So Exhibit Hall D is where you want to go for lunch after this. There are lots of volunteering opportunities at PyCon. It's a really low commitment thing. It doesn't take a lot of time, and it's a lot of fun. There's swag bagging this afternoon from 4 to 8 p.m., and I've been assured that the obligation there is just to come and stuff 10 bags or so. Drop by for half an hour, meet some people, have some fun, and then go on about your day. The registration desk also would really appreciate volunteers at any time. Just doing it for 1 or 2 hours is a huge help. But if you choose to do it on Friday, then you get an opportunity to meet everyone as the masses descend on PyCon. So it's a real great way to feel good and to help take ownership of the conference to volunteer. To see the current volunteering needs, you can go up to this bit.ly link, PyCon volunteering status. That's actively we need X number of these kinds of volunteers. And more sort of general information is out at bit.ly/PyCon 2013-volunteer. So I'll leave that up for a second. Volunteering is a lot of fun. You should do it. It's great. And then this afternoon, or when we're done, it's really important to please give feedback about the tutorials that you've attended. Use either the SurveyMonkey link or the shortened link, goo.gl/big P little v big H big D little c. Go out there and tell everybody what you thought about the tutorial, and be honest, because your feedback really does help change and improve the tutorial process here at PyCon. So like I said, my friend Dave is coming around with the handouts, but I'm going to go ahead and get started here. As you can maybe guess, some of you from the title of this talk, I still have feelings about Firefly. This deck originally was filled with wonderful stills, but I decided maybe I didn't want the copyright folks coming after me, so we get Grumpy Cat today, who's serving a dual purpose. So I want to ask you a question. Who out here has a vulnerable web app that you run? Show of hands. Who runs a vulnerable web app? Okay, great. So you spoiled my follow-up question at the end. Good job. So why does security matter? Why does web app security matter? Well, so it matters for the safety of your users, right? The people who are depending on you for your service, who are trusting you with their data, who don't want to get hijacked with malware or have terrible things happen to them. The safety of your data is also really important, right? You might be storing medical information, credit card information, your users' personal information, which becomes increasingly important as different countries institute various regulatory frameworks around personally identifiable information. You don't want your data getting leaked out to the world. You don't want your password database getting compromised and you find out, the world finds out that you didn't salt your passwords or something. So that's no fun. And then obviously it's important to your business, right? Think about the kinds of harm that can happen to you in the event of a breach or data compromise or some kind of takedown. That could be anything from, you've had your systems compromised and you can't run your service anymore, to now I have to pay hundreds of dollars per compromised credit card for all of the identity theft protection and those kinds of services, which I think runs about, it can be as expensive as about $200 per compromised record. So that could be, if you're holding a lot of data, that could be a real game over moment for you. So there's a group called OWASP, that's the Open Web Application Security Project, and they're a nonprofit that's focused on improving software security. And they provide documentation and tools to help learn about security and protect your applications. And every couple of years, they update what they call the top 10, which is a list of the most prevalent web application security flaws. This is based on data from 8 different firms and has hundreds of thousands of vulnerabilities that they categorize and index and mine through. And they select and prioritize these based on the prevalence combined with exploitability, detectability, and the impact to you and your systems. And they just updated it for 2013. So in your handout, you've got the release candidate 1 of the 2013 top 10. So, ooh, exciting. So what we're going to do today is we're going to talk about each of these vulnerabilities in turn. We'll do a little bit of background information on what it is. We'll actually attack a specially vulnerable web app that we put together. So you'll get to try on your bad guy hat and see what it's like to think like a bad guy today. And we'll discuss prevention and give some Django-specific advice where possible. And I just also want to give one disclaimer that the things that we do in here today against our own machines are for our educational benefit to help us secure our systems and things, and that some of the things you might be doing in here or learning about in here, if you did them to another company or without permission, could be considered a criminal act. So both we and PyCon are not responsible for anything you choose to do, and if we find out that you've used knowledge for evil instead of good, we will be very cross indeed. So please, use this information responsibly and for your education and not to go be a terrible person. So setup. If folks have not gotten set up yet, we'll go through sort of the happy path first of making a virtual env. Everybody got the virtual env going on? Okay. So you've seen all this stuff is in the handouts and stuff as well. So you set up a virtual env, go into the directory, source the bin activate. I apologize in advance for the typo in our handout that has the slash in front of bin because I was stupid. Folks, I think, have been either cloning down the repository already. If you haven't, you might want to, if you've already got it pulled down, you might want to do a git pull just to freshen it up, as I think Dave and I were making some last-minute small tunings to it last night. And then installing the dependencies is just running pip install -r on the requirements txt. Now, if folks are not there, you're having troubles with the network, the USB sticks are going around. And basically, we want to unzip the source code and then install the dependencies just off the stick. And then when you're done with that, go ahead and pass it along. Who still needs the USB sticks, if anybody? Okay. Another thing I'm going to recommend also is, to help us save time, we might like you to pair up with somebody who's already got everything set up. So that way it gives you a chance to talk with a partner, kind of collaborate on some of the exercises, learn from one another. Dave, you had, I think, things to say about pairing and some benefits.
A lot of people probably don't like to pair and would rather not pair, but it's actually one of the interesting things about this exercise to talk through possible attacks and how you might go about doing it, and it's a lot more effective when you have somebody else to talk to. So definitely think you should pair up.
And you want to give folks a minute or two with the USB sticks here?
Yep, go down there.
Okay, cool. The instructions slide for the USB. Okay. All right, and then once you've got everything installed, you want to go ahead and start up the application by running Python manage.py run server. So if you've done any Django, this should be real familiar. It's basically starting up this deliberately vulnerable app locally on your machine. Now, the nice thing with Django is it's going to only run it on localhost and not be open to the world. So none of your fellow classmates will be able to clobber your machine by hitting any of the actual exploits that are in this. But if you are sufficiently paranoid, you may be interested in not having your Wi-Fi on for a little while. I think they're like you can tell Django to run things on 0.0.0.0, and it'll listen and for anybody traffic from outside your machine, and that might be bad news if somebody was going to be mean in this class. So please don't be mean. All right, so as we mentioned, pairing is a really good idea. If you aren't set up or you're having setup issues, finding a buddy to work through things with would be a really good idea at this point. And say hi to your neighbors, because making friends at PyCon is awesome. And then I guess let's go ahead and get started, Dave. Okay. All right, so everybody's got their server running. We're going to go ahead and get rolling. So the number one vulnerability we're going to talk about is injection. So injection attacks are when your application sends untrusted data to an interpreter. It's going to result in some data loss or corruption, lack of accountability for things that are happening in some back-end system, or even denial of access. And for bonus points and fun, it can also even lead to a complete host takeover. So it's important to trust nothing when you're taking in data from the world. So that could be an external user that's sending you terrible data. That could be an internal user that's either disgruntled or unwittingly duped into sending you something that you don't want to accept in, or even an administrator account that's in some way either compromised or duped or disgruntled. And there are lots of things that you have to watch out for when you're talking about input coming into your application. So there are the get parameters that you might have in the query string, post data that's coming at you, things in the path info if you have dynamic URLs. If you're not sanitizing the dynamic part of that URL, it can do bad things to you if your application is not careful. And there are headers like cookie and host that can cause badness to happen. And I think even the recent Django security releases have had some stuff about host header poisoning. You also have to worry about files that users might upload at you. So what kind of things can you do if you're doing an injection attack? Well, you might create malicious SQL or some other kind of query to beat up on a database or an LDAP server and do bad things to it. You might access a private file on a disk. Maybe you'd really like someone's Etsy password and see what accounts there are or try to crack their passwords. You might execute arbitrary code, and that would be no fun, right? That's bad news. And no one is really immune from this. There's some really prominent real-world examples out there. So one is Sony PlayStation. That was a series of injection attacks that compromised 70 million plus accounts with personal information. Did they get billing data?
I don't think so.
Yeah, but tens of millions of accounts compromised there. A couple months ago, you probably heard about Ruby on Rails having a really bad day with the YAML parsing that it was doing in an untrusted way. So you'd shoot some YAML at it and do very bad things. And on a more personal note, Dave, do you want to tell them about the ESPN thing?
Sure. So I am an avid fantasy football player, and I was using the ESPN site to manage a team last year, or a couple years ago. And I got to an error page, which was really interesting because it actually had the message that was in the page in the query string. So at the time we were doing a lot of security training, so just to kind of fool around, I went through and tried to see what I could do. And this is a really simple example because I actually fixed a lot of the security flaws. But my initial example was actually my photo, and it said fantasy football profile and had a bunch of information about me, links back to my own website. And it looks like it's on ESPN's site, which is kind of interesting. And the icing on the cake was that when I used Bitly to actually shorten the link, I got an es.pn link. So it looked official. So I could send that out to anybody, and I sent it on my Twitter feed and said, hey, I'm recognized as a pro fantasy football player. And It was just a simple security flaw. The bad story about them is that it took them probably a year and a half to actually go back and fix them. I was on the phone with their security people once I reported the issue, and they said that they were getting it taken care of, and eventually they did. So you can only inject text, but no more JavaScript or anything like that. But there's a lot of cool things possible.
So the first exercise we're going to do is a SQL injection attack against our vulnerable web app. So basically this is where some unescaped user input causes the premature end of a SQL query. And that allows you to do something malicious and evil, like drop a table. So point your browser to localhost 8000 and you hit get started and start walking through the navigation into the attack, or go directly to the URL /injection/SQL. There'll be some instructions there, and start banging away at exploiting this query.
Yeah, as you go through the exercise, once it detects you're starting to go through it, it'll try to give you a couple hints to try to tell you what to do. It also gives you a link for the solution, but don't click that and see the solution until you try it for a little while to try to try actually to do the exercise. And then at the end of the time period, we'll go through, show the solution, and kind of walk through what it is.
And in the interest of time, we'll probably run these for about 7 or 8 minutes, let you bang on it for a little bit, and then show the solution and keep moving.
We'll also walk around and help people if they have questions or comments about the exercise.
Should I switch over to the other thing? Oh, I've got the timer going. If I had two screens, I would throw up the web app too, but.
You can do that. Do you want me to show the solution? Do you want to do it on?
Yeah, I don't want to. I'll pull it up on a big screen with the solution.
Maybe get people in a second.
Yeah.
Into it.
Yeah, we want more time on, so I'm not expecting to do that. Much like that.
Yeah. See those two.
Yeah. So I think most people have gotten there. So this was. So basically what we're doing here is we need to end that open quote that we were inside, because we're injecting into that open quoted spot in the query. So that's why we need to start with the single quote. We want to add on that semicolon so we can get a second statement going on, and tell it to drop the table. And then this comment at the end is so that any other SQL that was in the original query won't get executed. Anybody have questions about that? So don't do that. All right, should we pop over to the next one, you think? Yeah. Mm-hmm. What if the original query is just a broken query at that point? So if it's all getting crunched down onto a single line, having that dash at the end, that's a comment in SQL. So that's like in Python having a pound sign or an octothorpe, and then everything else is a comment.
Say you had a query like insert into something values percentage pass, and then you come in with that open bracket for and then you get for this query. That original first portion of that SQL.
So not all SQL is going to be injectable, even if you're doing bad things, right? So like in the case of like an insert statement where you wouldn't be able to do this kind of injection, an attacker would use a tool to try to find other places they might be able to do this. And with inserts, depending on the database, there might be other attacks they can do. If they can somehow use some other exploit to figure out using Oracle or MySQL or whatever, there might be other things they can figure out how to do based on that. But yeah, this won't work for every single query. It's just one attack vector.
And if you haven't read it yet, definitely check out the XKCD about this. Google for little Bobby tables, It's put a smile on your face.
Does anybody do this in their current apps? Actually just concatenate strings together for their SQL?
A
couple
brave
people.
soul back there.
For now, people who can't admit it.
Yeah.
Instead of running it through the DB API parameter substitution.
Right.
Right.
Yes.
And is that, how protected is that? Like 100 for 50, 10% protected? I mean, DB API inputs?
I'm sure there probably are or have been in the past. I'm not sure of any that are currently problematic. So the question was about DB API and how you would use like binds and other things in the API as opposed to concatenating strings together. So I don't think there is a whole lot of current exploits for that, but it doesn't mean there won't be.
Yeah.
But that does protect you because it doesn't do the string concatenation.
And we had a question over here.
I'm thinking, where is this actually being executed, or is this just fake?
Some of this is fake in our app. So yeah, the app is kind of a toy. So there's some Python on the back end that's putting together that query, not checking the input, building up a string, and if it looks like kind of what we're expecting to do today, then it tries to normalize it to something that's kind of like what it expects as a broken, hacked thing. Then it'll spit you out the message. Otherwise, it'll give you the hints.
So we don't actually have code that is vulnerable to this to look at, right? Is that right?
There are
It builds the
probably
query for you. So if you look at the
Yeah.
code itself, you can see where it does the dumb concatenation, but it doesn't actually execute it. Because the
Yeah.
first time you do it, you wouldn't have the table anymore, and you couldn't ever try the exercise
the
again.
one that I think is actually a legit real thing that you want to be kind of careful about is this next one, because I think we actually have the full file system
Yes.
open on that.
You can
It's
mess
fun.
your machine up if you do the wrong thing.
Yeah, it'll be fun. All right, one more question in the back, and then let's.
About injection, the SQL injection one.
Yeah.
Isn't that like the code behind that, like purposely made to be able to be easy to do?
Yeah.
Like I normally just think whether you have an ORM, an instruction layer in a database.
Yeah, absolutely. Yeah, if you've got an ORM, or if you have to build your SQL by hand, use some kind of like bind value facility to let you have those parameters injected by the database interface and not by goofy things that you've done as a developer. So yeah,
And
so
after
use those things for sure.
After the exercise, we actually go through a couple of the things that could help prevent
Yeah.
against these things.
Yeah. So for our next exercise, we're going to access some private files on your disk. So we're going to do some file system access and some unvalid user input that allow attackers to navigate your file system. So if you hit next off of the last thing you're on, or you can go directly to the URL there, and that's the next exercise. And I don't think this one's too bad. This is basically a game of dots and slashes.
Yep. It's a simple one.
So we'll do like, what do you think, 5 or 6 minutes? 5 minutes?
Go for 5.
All right.
A lot of websites do this kind of thing where they actually expose files that aren't in the doc root out to the real world without filtering the actual file path. So if you look at the example here, there's a simple photo sharing site where the actual token in the URL is the real file path when it's concatenated onto some other like constant in the application. So an attacker thinking that this may be the case will go and do some experiments to see what they can actually access through the app. So like in this case, you can get to basically any file in the file system just by navigating with dot to go up directories. So it'd be any file that the user that runs a web app is allowed to access. So if they're allowed to see etc password, you can grab the password file. If they're allowed to see shadow, and that's where like Unix usually keeps the real password hashes, because the app runs as a privileged user, you can see the passwords. Does anybody have this kind of problem in their web apps that they know of? Two hands.
Brave souls. It takes a lot to admit it. I understand.
Most of these we've had on our app over time, right? This is how we're kind of learning these things and understanding how to protect against them.
Yeah. All right. So the third and last of our injection exercises, we're going to execute some arbitrary code. So some bad input is going to be dynamically evaluated and executed, and danger. So that's the next thing here. Let's load that up. So we've got a vulnerable form here that is either going to be exec'd or eval'd when something comes at it. And we'll do, what do you think, 5 or 6 minutes again?
Do 5 again.
Yeah, okay, 5's good.
You can keep on track.
Yeah. Let's see. So basically, we want to open an interactive session. We'll grab base64 by importing it. And then we want to base64 encode string the command that we're going to do. So in this case, we're creating a file object, pwned.txt, and in write mode. And we're telling it that we're going to write boom. And then we'll do this into our text box, shall we?
You just click do it.
Oh, does it have a do it? Oh, good. I was actually going to do it. Okay, so we get this nice garbagey base64 value. And oh, congratulations, we've successfully owned ourselves. Now, the fun of this is actually dropping a file on your disk. So this is the other one that could mess you up if you did bad things.
Yeah, if you pick the wrong path, it'll overwrite files you have access to.
So don't do that. Okay, so let's talk about prevention of our... Oh, yeah, question.
What's going on underneath the hood? Executive being called. Like, why would the web developer put a call to executive?
So there's been a lot of cases, and there's open source apps that have done this over time. Our app in the past has done this where we needed to hold data around, and instead of using a data format, we would use like executable data formats, like either Python or something else that we could exec very quickly into a Python
eval,
object.
yeah.
Or eval it into an
Yeah,
object.
I think eval was our thing that we squashed pretty hard.
Yeah, so that's one of those things that's just a convenience that you don't realize makes you open to attacks like this.
So I had to parse JSON in Python before, and I couldn't install JSON packages. So basically, you just take the string, substitute true out for the correct JSON to, and eval it and use it. So I'm using it on internal stuff, so it's not an input.
Right.
So there's a comment on one of the reasons that someone in the audience was doing it is to actually, since they didn't have a JSON parser, to do some string substitution, then eval it back into the Python objects. So there's cases where it's a convenience, but it's just not there's a big security trade-off for that convenience.
Yeah. Now, one thing that you can do if you need to do evaluation of like a dictionary is you can use the AST module. It has a literal eval in it that will, if you're taking a serialized dictionary and you want it to be a dictionary again, but without blowing up and having weird eval or exec kind of side effects, you can use that literal eval in the AST module, and it'll just give you back either a data structure or it will blow up and die because you fed it something it didn't like.
So the solution, again, I just wanted to get a quick look at the solution again.
Oh, yeah.
Sure.
So basically, we're doing this base64 import. Yeah. And if you've got the app locally, it will have a show a solution button there. So everybody's got to check out. You've got all the solutions as well. And it makes this garbagey, awesome base64 stuff. Okay, so Dave, you want to talk about prevention?
Sure.
All right.
I mean, the main thing is that you want to validate all user input. So in our cases, we're doing a lot of query string stuff or form validation. But there's also host header things or headers that you want to deal with, like the host header and cookie. There's file uploads. There's things that if you do WebSockets, right, there's a lot of communication back and forth between client and server. Everything you can consider untrusted and make sure that you deal with it appropriately. So signing is another big thing where if you give data out to the client, right, you want to make sure that it's the same data you gave them when it comes back. So doing signing on either like cookies or even some of the form fields. ORMs, and this is one of the comments from the back earlier, that if you use the ORM or you use bind variables, you don't actually have a lot of these same like SQL injection problems because it takes care of that stuff for you. So you definitely want to use that. And then all formats that are technically executable, you want to be sure when you use it that you're doing it in a safe way. So like YAML is a great one that the Ruby on Rails guys had a problem with recently. But Pickle and anything that you're going to feed through eval or exec, you want to make sure that you control what that data is. So For Django specifically, you want to make sure that all the data types for all the models are correct and tight so that you just don't have a bunch of strings that people can put anything into. You want to make sure you get very specific types. Forms or model forms. Model forms kind of do things automatically. You want to make sure that you tightly wind what people could give you through some kind of set of validators that maybe you control that are very app specific. So if you know that it's a very specific integer, check for that. Don't just say it's an integer. Be very specific in those kind of things.
Yeah, absolutely should not be afraid of making new validators. They're your friends.
Absolutely. So regexes are another one where you can actually inject into the path info. So you want to make sure that all that stuff is as tight and as concise as possible.
Right. Let's say like you're an e-commerce site and the category that you're on is part of the URL so that you can have nice SEO hotness. And you just take that value, and if you just put that into the page, well, that's bad news. Nobody here would ever do that, though, right? And like we said, use the ORM when you can. And if you can't, use extreme caution.
Extreme caution.
Yeah. If you've got some interface that lets you do bind variables, that's really important. Like the Oracle stuff does that.
Most DB API libraries do that as well.
Yeah. And please, no string concatenation or formatting of anything unsanitized that came from the client. You can't trust it. It's bad news. And
it's not only bad news, but it's something that could affect you later down the road when you don't even realize it because you stored that in the database and eventually comes back out to you. So you would just want to make sure you always up front sanitize everything.
Yep.
It's not just the client. Sometimes it's not from your own database. But you
right.
Yep.
So even if you're getting it from your own database.
Yep.
Exactly. So the comment was that you can even get it from your own database or maybe even third parties, right?
Yep.
Don't trust anybody.
Okay, so number 2, now that we've gotten through one of the longer sections, is broken authentication and session management. And this is basically where an attacker uses leaks or flaws in your authentication or session management code to impersonate other users. And all the sort of roll your own solutions that are out there that people tend to implement your own because it's not that hard to write one. That really contributes to the difficulty of finding all of these sorts of things. So things that can happen if you're vulnerable to this include compromised user accounts, worse, compromised administrative accounts, and the unauthorized use of privileged functionality. We don't really have any exercises for this because Django does a reasonable job out of the box. So we're just going to talk through some of the prevention and mitigation stuff before we get into some more exercises. So hash or encrypt your passwords, LinkedIn. Who else has been in trouble with this lately? Somebody the other day had a thing with this. Evernote.
I don't know
Yeah.
they were very poorly hacked.
Yeah. They're MD5 though, so that's cool, right? It's only for internal systems. What could go wrong? Don't let your credentials get easily overwritten. Like if you make it really, really easy to overwrite somebody's password, then that's bad news if you can get especially an admin account. Obviously, don't put session IDs in the URLs. Django is really militant about this, which is good. But don't do it in general. I cringe every time I see a session ID in a query string. You should be allowing your session IDs to time out. And you should also be allowing users to log out. A lot of apps, like if you forget to do a logout button and somebody uses your app from a shared computer like a web cafe or a library, they can come along and continue to be you. Yeah, question?
So what's the logic behind session ID from your Docker session ID? Just because over the...
Right. So, over the shoulder or browser history, right? Because if it's a get, then and you're passing that around, then that's out there.
Just having it in the query string is dangerous because anybody could grab that from any proxy along the way, or any evil person that's in between you and wherever you're trying to go. If you're over SSL, a lot of this stuff doesn't directly apply because things are taken a little bit, so since it's encrypted from point to point, but there is still some potential for the browser history if you're on a public machine. So
right.
Go and look and see what it was.
Or you might be in a corporate environment where they're decrypting the SSL on the way to make sure that you're not trying to steal credit card numbers. So you can't always trust the SSL even, which is kind of scary and sad. Rotating session IDs after successful login is probably a good idea so that your session ID doesn't persist forever. And having some kind of transport security for any time you're dealing with passwords, credentials, session IDs, that kind of thing is important. And we're seeing more and more of this as sites are going all SSL for their logged in areas. So some Django-specific advice.
So you definitely want to use Django Contrib Auth just because they've taken a lot of this stuff into account and they've been building this. And if you do it yourself, you're going to basically be opening yourself up to any of the attacks that they've already found and fixed. And there's a bunch of other stuff out there on GitHub and other places where there's middleware and other add-ons to Django to make things more secure. Like in this case, there's a Django session security middleware so that manages the timing out, which Contrib Auth does not do.
Yeah, and I should point out, we'll also have the slides up this afternoon, and I'll update the README on the GitHub repos with a link to the slides, so you don't have to freak out about trying to write down any URLs that you see in the presentation today. And we'll talk some more about transport layer security a little later on as well. So cross-site scripting is one of these that has a fun acronym, XSS. So this is the most prevalent actual web app security flaw that's out there. And this is when your app includes some user-supplied data in content that gets sent back to the browser without validating it or sanitizing it. So there are basically like 3 flavors of XSS. And the first is stored. So this is where we've got injected code that's permanently stored in like a database or a message forum or a comment or something. Like we had a comment from the audience about not trusting the database. There's reflected cross-site scripting, where code gets injected in a live request to the server and then gets reflected back in the error message or a search result or something like that. So like if you enter text in like a search box and that is played back into the page without being sanitized, much like the...
That's exactly what I did for that ESPN thing.
Yeah, like the ESPN thing. And there's also what's called DOM XSS, where the code that you're doing, some kind of malicious code gets injected in the DOM environment in a way that causes the JavaScript that's on the page to read that and then behave in some unexpected way. Like it might be expecting to read some value out of like a data attribute on some element, and if you can get into that and crack that, or maybe it's doing a query over like a bunch of different nodes that it wants to find, and then look at the data that's in there. If you can get into that, then it might be an avenue of exploit. So some possible things that can happen to you: you can execute scripts in your victim's browser. And what does that mean? Well, you can hijack their session, you can deface their website. Real similar to the Hello PyCon thing that we showed this morning. You can insert hostile content that does bad things. You can redirect them. You can go hijack the browser and send it somewhere else that might hit them with some malware and some other things that you could use to leverage into another attack. And this is most often seen in places where user-created text gets displayed to other users, so like a comment or a message board. So you have to be real careful in that. Any kind of form inputs where the value is getting populated with user-supplied data without being sanitized. Or in script tags where user-supplied data gets populated into some variable so that you can have your JavaScript work on it. So we're going to do a couple exercises with this. For the first, we're going to manipulate the path of a URL and get something bad into the page. So go ahead and load up the next exercise. We're going to skip that. Insecure path matching. So basically, we're going to do some bad stuff with the path. What could possibly go wrong? I'll give everybody about 5 or 6 minutes to play with that. Timer's up, so we want to look at the HTML, and we want to modify the document title. There's a piece of script that loads off the path. So we can go in here and add some closing to that JavaScript variable, and then set the document title to "Please hack my users." And so now we've got our our titles changed out. Make sense to everybody? Success. Okay. So the path is not the only place it's vulnerable. Another place we can attack our users is with the query string. So you can trick somebody into visiting a legitimate-looking URL that has some garbage in the query string with some unvalidated user input. We can get that included in the page as well. And that is the cross-site scripting with query parameters exercise. So in this exercise, we're going to add an image element into the DOM and have some particular image in there, and some bonus points if we figure out how to hide that from the users. I think about 6 or 7 minutes on this.
I'd go higher, 6
Like
or
8,
7.
10?
Go 7.
Okay, I'll go 8. Okay.
So the solution for this is a little bit complicated, but pretty easy once you step back and think about it. I did it all in interactive Python so that you can see kind of what I did. Essentially, if you pasted this into your interactive session, and then the output of eurolib.quote could go directly into the query string. And so it basically just ends the existing JavaScript. So if you looked in the page, you can see where we just leave in part of what was in the query string into the JavaScript. So we end the existing JavaScript so we don't cause an error. We inject our own. So in this case, we create the new element. We add the source. And then we add the attribute display none so the user can't even see the image there. So in this case, the image renders. It pings the server in the background, but the user never knows that happened. And then we append it to the body. Right. After the body, you can see there's a couple extra quotes. That basically the double quote just closes off the existing JavaScript so that, again, the JavaScript doesn't have an error. And at this point, anything you could fit in the query string that's JavaScript, you could actually execute. You can delete the page. You can rearrange the page. You can reload your own content from a separate site. So there's a lot of bad things you can do very easily.
Harvest all the session credentials and beam them to some bad guy. Anything that's in there. Imagine it was on a payment page and you scraped somebody's credit card data.
Yeah, that could be very, very bad for you.
Yeah, so and here's all this stuff once it gets quoted and injected into the URL. All right, and then for the last of our cross-site scripting exercises, we're going to exploit a form field where the value part, or the value attribute of some input in the field is going to be prematurely terminated, which allows JavaScript to get injected into the element itself, for example, by adding an on-click.
So here's a question. How many people are running Chrome right now to do the tests? Okay, what about Safari? Okay, all of you guys, the exercise won't work because the browser is really awesome and actually doesn't let you do this. It gives you a warning in the console saying, hey, we won't execute arbitrary code. If you're using Firefox, for sure I confirmed that it works. So you can actually exploit Firefox pretty easily.
Yeah, I think one version of IE is probably blocking this now.
The newest IE, I'm pretty sure, blocks it as well.
It was when we were running some of these at work recently, because IE is not our primary thing that we look at. We were surprised when some IE users were like, hey, I can't do this, but other people could. And we're like, wait, IE did a security thing first? What?
So, I mean, the interesting thing here is that browser vendors are starting to fix the things that web app developers can't fix or don't know to fix. So that's actually a good thing, but in our exercise, it's obviously not ideal because I would want to show you what this would look like. So maybe
do I need to? I can launch Firefox.
So we'll do a real quick by hand demo.
Let's see if it actually does it.
Just do like a simple alert.
What is this with the? Oh no! Look at that. Maybe my Firefox doesn't. What Firefox did you have?
1902
or 18? Oh, wow, mine's really old. So you're actually doing stuff in here? That's what we're trying to do?
Yeah, so do a double quote greater than.
Yeah, here.
So you need to close the form.
Right. Oh, right.
And then do a script tag and then alert and script tag. And then I did a start of an input that was hidden so that the rest of the HTML was okay.
Like so.
Take off the last double quote.
Oh, right,
That's
right.
actually in the
You're right, because we're injecting into that quoted section. Ah, look at that. Yeah, so
if you try this exact example on Chrome, it would give you an error message saying it can't do it. But obviously Firefox isn't as awesome at that yet, I hope. So we'll skip this one because most of you can't actually do it.
yeah, it's more fun if there's more of a mix of browsers out there. But the Chrome guys are being really proactive about it. Yeah. Yeah.
So the positive story is between Django and some of the other frameworks actually trying to make it hard for you to do things that are bad, and the browser's trying to protect you on the other side, that these things are getting less and less utilized by attackers, but there's still a lot of things you can do to yourself that actually cause these things to happen.
Are there any legitimate uses for that where like the browser trying to make you safe would get in the way of wanting to do something reasonable, or is it?
Security tutorials.
The question was, is there any legitimate use of this that the browser would get in the way of? And I don't think so, because what it's really trying to do is saying that there's executable script in this page that was also in the URL or in the post variables, and usually that's a really bad thing. So I can't think of why you'd want to do that, because you can always get around that.
Okay.
Strange that Chrome bit for me just doesn't do anything. It just doesn't.
If you look in the JavaScript console, it'll give you an error message that says that something to the effect of the request, the JavaScript was in the request.
Yeah, and then if you're viewing the source, you'll see like the source getting mangled.
It actually strips the JavaScript out for you, so you can't even see it in the source code.
All right, so we had a question earlier that we wanted to touch on here again. Can you trust your database? What do you think?
Hands for yes. Can you trust it?
All right.
Trust nothing.
Good, good. All right, so let's talk about preventing this stuff.
I mean, the simplest thing is just escape all of that untrusted input so that those literal quotes can't get into the JavaScript or get into the page to close off HTML elements. Whitelisting is also a really good thing. You want to whitelist the possible values that you would expect to see.
If you can.
If you can.
Like in, say, like an input of states of a country that you're validating.
Right.
Like
Don't
you want to
accept
see only those particular
Don't
things.
accept quotes inside
Right.
the state field.
Yeah.
Also, sanitizing libraries. There's a lot of things available to help you actually look through the data and figure out if it's data that is malicious.
Yeah. OWASP provides a library called Anti-SAMI. I don't have any experience with it personally, and I don't know if it plugs easily into Python, since I think all their examples are Java-based.
There's a Java and a .NET version.
Yeah.
There's no
So,
Python
but
version.
it's at least something to consider. Like you can look at it and try to learn from it, and it's all their stuff's open.
But if you use Django, use the forums,
Yep.
right, and provide very explicit validation on those form fields.
Yep. And as we saw with modern browsers, consider updating your parents' or your in-laws or your significant others' browsers so that they don't get jacked up by one of these things. So some Django-specific things.
So there's actually a bunch of stuff in Django that allow you to mark data as safe, because Django will automatically escape stuff going into the page for you. And then you want to say, hey, maybe this snippet is from our CMS, and we trust the users in the CMS. All of those cases where you might want to trust the user, you want to think twice about it. Maybe in the CMS provide some validation that they can't use script tags, or do something to that effect so that they can't either accidentally or maliciously add stuff to the page. And then escape, right?
Yeah,
There's a template tag to actually escape stuff for you. So you want to make sure that things that aren't being escaped automatically, you escape explicitly.
Yeah, so be real careful when writing your own template tags. And when you're laying out your forms, using the as p, as table, or as ul convenience functions, that'll make sure that things get properly escaped for you.
Yeah, Django does a good job if you just use it out of the box the way they intended.
Yeah, its security story is definitely improving and I mean pretty strong anyway, but continuing to improve, which is really nice to see.
And as they find things, they fix them. So if you're using one of these things, they do find a flaw, they'll fix it, and you'll just get magic when you upgrade.
Yeah, pay attention for upgrades for sure. All right, so vulnerability number 4, insecure direct object references. So this is where a reference to some internal object is exposed without verifying that the user has the right authorization to do stuff with it. So an attacker can just change the URL or change get parameters or post parameters or change, alter their cookie and start exposing or even manipulating data that doesn't belong to them. So this can lead to compromise of all data that can be referenced by that vulnerable parameter. Maybe it's a ID of some record or something in the database. And unless your namespace is sparse, an attacker can just start walking across all the data of that type. So if you see something that's like, email number 123, and you can change that to be show me number 124, and then now you've got somebody else's information. So we're going to do an exercise to manipulate parameters in the URL to access data that doesn't belong to us. So that's in our next section on direct object references, and I'll get to that here. Say goodbye, Firefox. So in this exercise, imagine you're logged on with user ID 1, and there's a user profile page you can visit. What else can you do? And we'll give you a couple minutes with this. This one shouldn't be too bad. Oh no, user number 2 is an admin. And you know what? Let's change his email address so that I can own that now. And while I'm at it, I might as well change his password. So now, because all this page checked for was maybe that you're logged in, but not that you're the right person, now I've just hijacked an admin's account. And I can do who knows what.
And some of that exercise seems a little silly, but it's actually happened in the past. And people continue to do it because they don't really think about it when they're going through making these pages. Question?
How would you actually do that in like a real Django app? Is it okay to use the self.request user, like in your template or in your code?
Yeah, so the question was, how do you do it in a real Django app? And yeah, I would do self.request.user, or I would use some mechanism, depending on what things you're doing in your authentication framework, to make sure that the user that's logged in has access to it. So it's not just that they have a user and it's not an anonymous user. They have to be able to, via permissions or some other mechanism, have access to the data they're asking for.
Right. So there's a permissions architecture that you can use to lock down the views in terms of the authorization. Another thing that's fun to do is customizing the query set in your model so that when you're looking up objects, you're looking up in a way that always is involving just the things that that user can see or that user can do. And in general, implementing some kind of access controls is really essential. And one interesting kind of suggestion that OWASP provides is implementing either per user or per session indirect object references. So let's say you had a drop-down that had 6 items in it. Rather than the value of each of those things being the literal value that you would want to store, you might just have it indexed, input value 0, value 1, value 2, value 3, value 4, value 5. And on the server side, map that back into the actual data that you want to manipulate or the data that you want to use. That's a little bit of extra overhead and process to think about it, but certainly an interesting way around that. All right. So I think we got time for the security misconfiguration section before the break. Should be fun.
Sure.
So this is one where maybe as developers, if you're not an ops person, you might not have as much opportunity to screw this up. But basically, in a security misconfiguration, you've got some kind of insecure application settings, unpatched flaws, or pages that aren't used anymore. And so, we don't use it anymore, but nothing could go wrong, right? So nobody looks at it once it's out there and old and sad. So possible things that can happen to you with this. You can have unauthorized access to some data or functionality, or even if it's really bad news, a complete system compromise. So we're going to do a couple of demos and have some discussion around misconfiguration, and I'll pull that up. And then, Dave, you want to do the discussion stuff?
Yep.
So the first one is the secret Django debug toolbar. What's the bad news here?
So this is actually an idea that I found in a client, in a client code base when I was working on something where they had a magical way. So if you're not familiar with the debug toolbar, it allows you to see like all the queries that are executed, all the data about the request, and a lot of stuff about the server that you potentially don't want an attacker to see. And it's safe by default because it really wants you to whitelist an IP address. But this particular client wanted to be able to just turn it on in production and didn't care where the traffic came from so their developers could debug when someone said there was an issue. So they have this middleware that just checks for the secret flag and would enable the toolbar. So now you can go and you can see all kinds of stuff about the request and about the server that should be kept private. So like here you can see not only the header values, but you can look at the queries if there were queries that are running. So now you've got information about the database schema potentially, and you don't want attackers to ever know much about the database if possible. Django does a pretty good job of nulling out password fields for like some of the settings, so you won't actually see the database password, but you might see the database username, and some of this stuff gives you kind of that next step for like a social engineering attack. So this is very, very dangerous. You want to make sure that all this stuff is hidden where possible.
Oh, good. It blocked out the secret key. That's nice.
They're pretty good about that.
Well, they are now. This is why it's important to upgrade your Django. All right. And then should we hit this other one?
Yeah, which one is that?
The debug enabled in production.
Yep.
Okay. So this is what happens because Django is awesome, and when it throws a stack trace in your debug in your development environment, you get to see everything that happened. You can see your stack trace, your Python path, all kinds of stuff that came in, the request, all of your settings.
So if an attacker could figure out a way to force an error in your website, which sometimes isn't all that hard, they'll see this nice debug page with, not only does it have a stack trace, but it has local variables along the way. So depending on what stuff you're talking to, maybe you're talking to, maybe they cause an issue when you're trying to connect to Redis or something else. You'll see a lot of that information in the stack trace, maybe passwords, usernames, all sorts of stuff you don't want them to see. So debug off in production.
All right, should we talk about prevention here?
Yep.
All right, so how do we prevent our security misconfigurations? And who out there is an ops or a DevOps kind of person? Okay, so you guys be strong and help us prevent these things. Everybody who's just a developer, be nice to your DevOps or your sysadmins and encourage them gently.
Yeah, so I mean, it's really important to have a process in place for when you deploy your application to make sure that things are properly configured. Using something like Chef or Puppet or Salt to make sure that things are consistent across the environment. You don't have a lot of those lingering, fat finger kind of errors where something just accidentally gets exposed. You want to make sure that you're always up to date with things because, as we've seen with both Rails and Django over the past couple months, things happen, they act very quickly, and then they do some updates. You want to make sure you're on those kind of updates. But also system updates for software like Apache or Nginx or whatever else you have running in that machine allows people to potentially have another attack vector. So it's very interesting that a lot of people don't really take this stuff into account when you create an architecture for the layers of your software to make sure that there is a secure separation between all the components and you really think about the interactions between all those things. And so this is probably the key. There's a lot of free tools and there's a lot of commercial tools. Do scans and audits of your software, as much as you can. Some standards make you do it quarterly just to be, I think that's what it is for PCI. Right?
Yeah, but depending on your PCI level, they're either quarterly or semi-annually or
but you should,
or biannually.
You should definitely do them.
Yeah.
Right? Some people do them on every release, which may be a little bit overkill, but if it stops an attack from happening, it's probably not overkill.
Right. So Django Advice. Like we said, don't run your debug in production. Keep your secret key secret. Don't check your secret key into GitHub and publish it to the world for whatever you're open sourcing. Keep your Python code out of the web server's root so that you don't have people wander around and, what's this config.py or something that's out there. If you can help it, don't run the Django admin publicly. Especially don't run it on the same URL as your site. And if you have to have it out there, maybe don't run it under the /admin path. Obscure it at least a little bit.
I think most people probably do this now and have the /admin just publicly open. But if there's a flaw in that, your entire application is wide open. So you want to think twice about doing that.
Yeah, if you can, try to avoid using the built-in Django admin for normal user administration tasks, like letting your users, change their names or their passwords or their pictures or whatever.
Yeah, there's a lot of stuff in there they can get into that maybe you don't want them into or seeing. And if you just provide very focused ways in your application for them to do their tasks, it keeps them out of all that gory stuff.
So here's something we wanted to ask a question about. What about social engineering and security misconfiguration? How are these guys friends?
So social engineering is kind of one of those interesting arts. It's actually not very complicated for people that are remotely good at it and personable. And it's really just a matter of finding the weak link in the chain, right? So in the case of having that the debug toolbar and you know some of the data about the schema or file paths, you could potentially call a developer for a company and act like you're one of the employees at a remote office and actually give them enough information they feel comfortable giving you more information. And it's one of those things where you just get a little bit more and a little bit more from different people, and now all of a sudden you have the keys to the kingdom. Someone gave you the password at some point in time. It doesn't work for startups where there's 3 people and they all know each other, but for a bigger company you want to attack that has 1 million credit card numbers, maybe you want to steal, these things kind of allow them that entry point into your system through other people.
Yeah, like, hey Dave, did you see that crazy traceback?
Exactly.
What crazy traceback, Mike? Then it's all downhill from there. So we've got about 5 minutes before the official break time starts. Do you guys want to get into another section, or do you want to have a break a couple minutes early and then just come back a couple minutes early? Shout out. What do you guys feel like? Break early. All right, break early. Okay, so come back in about 20 minutes. So I think about right about 11 o'clock or like 11:05. 11:05 we'll start up again.
Sounds good.
Sound good to everybody? All right, awesome. So vulnerability number 6 is sensitive data exposure. This slide was originally Nathan Fillion sitting on a rock in the desert at the end of Trash, for anybody who's seen Firefly, but copyright and good taste had me change it. So just imagine that there. So anyway, sensitive data exposure. This is where some kind of failure to properly protect data like credit cards, tax IDs, or authentication credentials happens. And your sensitive data really deserves some extra protection. So that's encryption at rest or in transit, special precautions when you're exchanging it with the browser, that kind of thing. And this was actually recently combined from 2 other vulnerabilities. The first one was in the 2010 top 10 was called insecure cryptographic storage. So this is where you're not encrypting data that should be encrypted. You're maybe using an unsafe key generation algorithm, or you're not storing your keys safely, or you're not rotating your keys regularly. If you don't rotate your keys regularly, you stand a chance of something getting compromised. Or you're using weak algorithms when doing the encryption with those keys. I'm going to call out Evernote because they said MD5 was good enough for hashing their passwords. I don't agree. Or doing weak hashing or unsalting, not salting your hashes. So was that LinkedIn that didn't salt their passwords? So bummer. And then the other thing that this got combined from, we got a question in the back. Yeah, it was got out. Okay, so the comment was that there's a rainbow table used to salt their passwords, and that the rainbow table got out, and bad news. And the other vulnerability that got combined into this from 2010 was what was called insufficient transport layer protection. And that's where you're not authenticating, encrypting, or protecting your confidentiality of your sensitive network traffic. So this is data flowing over the wire. So maybe you're using insufficiently strong encryption for your SSL, or using an expired or invalid certificate, or a certificate authority that most of the world doesn't know about, or some part of the world doesn't know about. or you're using a certificate incorrectly. So when these things are going on, you can compromise all the data that should have been encrypted, like all those LinkedIn logins. And these kinds of things can be really sensitive. They can be people's personal data, their health records, their credit card information, user login credentials, things you really don't want to leak out. They could be really harmful to your business as well. You can expose individual users' data. This kind of thing can lead to account theft. So if you're not encrypting your connection back to your site and you've got a bunch of stuff in a session cookie, you can sit at the Starbucks Wi-Fi and run Firesheep and then be other people on Facebook, let's say, before they fix that. So you can have accounts being stolen. Would be really bad if you compromised an admin account this way. And poor SSL setup can facilitate attacks like phishing and man-in-the-middle attacks. So one thing that's really important to understand is you're not paranoid because they really are out to get you. A lot of examples of sites getting hacked through these ways, through this kind of avenue to then try to get shell access into a machine. And once you get into the network, you can sniff all kinds of traffic on the inside. So an attacker is basically monitoring traffic of your users. So like we said, this could be at Starbucks. This could be at your favorite conference's Wi-Fi. I hope everybody's running through a VPN or something. There's some good ones out there. It could be a back-end connection inside your server farm from your web server down to a database server or some other application that's running inside your farm. It could be inside your network. So to prevent this stuff, you want to talk about prevention, Dave? I'll let you run the keyboard. It'll be fun.
So any sensitive data you have, you need to make sure it's encrypted. And you need to make sure that you manage the keys appropriately for that data, including like offsite backups. If you need to encrypt those, you need to encrypt them well. And so typically the algorithms in cryptography are pretty solid. It's the user intervention and using the algorithm that's usually the problem. So managing the keys is probably the biggest one.
Yeah, don't store your key at the same offsite backup as your encrypted offsite backup.
It should be hard to find that key. You should manage that as probably the keys to the kingdom. The most sensitive thing you have is the key to decrypt all of your data. Always use standard algorithms. Right? You don't want to go and invent your own in cryptography because typically you're going to do it wrong. There's a lot of science behind it, and unless you have a really good CS background and a lot of faith in yourself, you probably don't want to do that.
And even those people screw up, right? It's really, really hard.
Absolutely. So hashing passwords, that's probably the thing that most people do incorrectly. So you want to make sure that you hash them and you do a secure algorithm across that password. So OWASP, I don't know the exact numbers, but they say you should hash it several times, so like even 1,000 times using a secure algorithm, so it's very hard to unwind that. And a lot of people do it at variable length so that you can hash the same password maybe 10 times and hash the next guy's 42 times, and then store the information about how many times you hashed it along with the hash, so that the next time you come in, you can repeat that algorithm. So there's a lot of advice on the OWASP site about how to do those kinds of things. And then you want to make sure that you have a truly random salt, right, and not just something that they could very easily guess and test across the passwords. Question? Passlib is good. Passlib is a great library for actually doing a lot of that hashing. And it does a lot of the things I believe that I mentioned, right? Cryptacular? I've never used Cryptacular. And then you want to protect all of those passwords and keys from the unauthorized access. So this is the ability for an ops team to manage those keys, because not every developer needs to have the ability to decrypt all the production data. So managing the passwords is figuring out who needs to have access, how they need to get the access, and where those things are stored so that only those people could get access to the keys. What's that? Bcrypt? This is another good algorithm. So this is really good advice, security and otherwise, is to require SSL for any sensitive pages or anything that contains sensitive data. It's very important because SSL actually protects you from a lot of the things that we've been going over with exposure to session IDs and other kinds of attacks where people pretend to be people they're not. Also, you got to be careful of the redirect non-SSL request to SSL. So this is a case where you want to do this so that people get to a certain place in your application that they're in a secure state. This is one thing that we actually just did this year, I think. Yeah. Implemented secure cookies so that certain information about the user, like the authentication of the session, is actually stored in a cookie that only gets transmitted over SSL. So this way you can't leak that information on an insecure Wi-Fi connection.
Yeah, and if possible, also the HTTP only flag on the cookie so that your JavaScript in the browser can't see the cookie at all. It's only sent over the wire between you and the server.
And again, strong algorithms. You want to use the highest encryption that you possibly can across your SSL. And this is kind of the interesting one. You want to make sure your cert is valid, not expired, not revoked, and matches your domain. And I would say that you want to do this even for your test sites, because one of the things that people tend to do is forget about their testing environments and tell the users, don't worry about the cert, just click OK. And that kind of trains them to do the wrong thing, even in production, when they don't realize it. So you want to make sure that they're all valid all the time.
And you also want to do SSL and encryption on your back end. So if you've got web servers on the front end talking to some authentication server on the back end, you want that to be encrypted too, so that if anybody's inside your network, they're not going to be able to see any of that traffic.
Yeah, I mean, what's scary is that some of those exploits before, you can actually get onto the machine, and now that you're on the machine, if you have the right privileges, you can monitor the network and look at what else is going on and kind of escalate to different machines, different systems.
So in a Django-specific world, using Django contrib auth is good for proper password salting and hashing. I understand there were some issues with that a few years ago, but I think it's better now.
Yeah, I think everything is good. And then, like the gentleman in the back said, passlib is what we use at our daytime job so that we could ensure that these things are hashed appropriately and securely. SSL, right? So if you use Nginx or Apache to front end your Python application, make sure that SSL is configured appropriately on those servers.
And then there's a bunch of ways that you can require SSL using Django middleware. We've got links to a few different snippets, and they all take similar approaches, and there's some combinations of things. So some of these do redirection of your non-SSL to SSL for pages that require it. Others are doing things like tweaking the URL tag in Django so that when you are having your templates generating URLs, you can have the secure required URLs actually say HTTPS in the markup that lands in the browser. So that way, that kind of prevents you from even having to do that redirection on the front end as a user coming in.
Yeah, it's definitely worth checking out those snippets just to see how they work.
Yeah, it just so that helps you in terms of a traffic and load standpoint. You're not having to do that redirect and load the page again. All right, any questions about sensitive data exposure? All right, cool. So it's more of the fun stuff. Number 7 is missing function level access control. So this is where your application maybe doesn't protect its functions properly because of either misconfiguration or you forgot to check because we're all busy and trying to get stuff done before deadlines. So some of the things you can do to attack in this way. So an authorized user could change a URL or a parameter to some privileged version of that. So maybe there's a page for showing you your thing, and there's a admin form of that URL. It's I think more common in like PHP that there's a foo admin to go with a foo page. So you might change that to be I can go hit the admin page with this now. And so there's also you can have anonymous users accessing private functions if those aren't protected as well. And you wanted to also point out that cookie doctoring can be, messing with your cookies can be a vector for this too, right?
There's a lot of cases where you store the session ID in the cookie so that you know the user is who they say they are. But there's other cases where they add in some additional metadata into the cookie to say whether or not you have certain privileges, like a little admin flag in the cookie. So as an attacker, if I notice that's happening, either by sniffing traffic or doing some other kind of social engineering attack and trying to figure things out, I might just doctor my cookie so that I can get that access escalated.
Yeah, and just because you don't publish a URL or don't link to a URL on your application, that doesn't mean that people won't eventually find it just by banging on it or trying all kinds of different combinations. So obscurity does not save you from that.
We've actually had that problem in the past where we had an admin page that a developer put out there so they can manage certain things and didn't realize that somehow Google found it and it was actually indexed. Right? We didn't link to it. It was just somehow it got leaked out there. So
that was fun.
Yeah, it's very dangerous.
Yeah. So some possible consequences. You can compromise user accounts, which is no fun if you're that user getting messed over. You can compromise administrative accounts. And again, the perennial favorite, unauthorized use of privileged functionality. So we're actually going to do that. We're going to access some privileged functionality by messing with the URL. So this should be next in a couple sections here, because we wrote stuff about sensitive data exposure. But we're going to do some exercises about this, but proxies don't see your localhost traffic, so it's not as much fun. So missing function level access control, we've got this kind of exciting flaw where we've got a URL that's vulnerable, so you can exploit it to attack our super secret admin area. Give everybody a couple minutes on that. Page that is most certainly not allowing us admin access. But what if we just used an action parameter to tell us that we can now have super secret powers? Oh, no, I hope no bad guys ever got in here. So it's not as common to use the query string to grant this privilege escalation, but there's still a lot of cases that you can get in and do bad things, like if you've got a cookie with an admin flag set. All right.
Question?
Yeah.
So mitigating that, I mean, you're basically back to your access control way that every action has got to go pass by the checker.
Yep. Yeah, so basically, for every page of your application, and you do need to know what every page of your application is. You don't want any surprise leftovers that you forgot about from 4 years ago kind of a thing out there. Consider every page and whether it should be public or privately accessible. If it should be privately accessible where authentication is required, make sure that your checks are in place for that. And if there's some additional authorization required, make sure that those checks are in place too. Make sure that they're the right level of user accessing it every time somebody's coming in. And in general, it's a really good idea to deny all by default and explicitly grant access only to particular users or particular roles using whatever your access control mechanism is. So in Django...
So Django's got a couple really good things that help you out, right? So it's got a built-in permissions architecture, so you want to take advantage of that if you can, so that you can set different permission levels for different items that you want to protect and who's allowed to see those. And that works in conjunction with the contrib auth. And then we had this discussion right after the break started where don't use a built-in admin for normal user stuff. So actually go back and think about what the users actually need to have access to and then build that, maybe using some of the Django admin components because a lot of those things you can reuse in your own admin, and lock that stuff down. So it's a lot harder to lock down something that you've just been given, like the Django admin, where there's a lot of stuff. It's much easier if you kind of understand what you're building. You have a small, focused application, and then you just lock it down as you go.
All right. Any questions? Awesome. So number 8, this is a little meatier one again, cross-site request forgery. And this actually dropped from one of the first 5 down to number 8 this year because people are actually really cracking down, developers are really cracking down on fixing these problems and preventing them, which is really, really good news. I think it was like number 2 before, 3. It was really high up. So this is where an attacker is tricking a victim into submitting a forged HTTP request, and if the user, the victim, is authorized and authenticated for whatever thing that you're being tricked to doing, then you've just got nailed with some attack. So it might be something like viewing an image tag that causes a get to happen inadvertently on some other site. Doing some cross-site scripting can do this, cause you to pull in something from another site or make a request to a site. Fake buttons and phishing forms that look like enticing things that you want to interact with, but it could be all decked out like your favorite website, but is actually, doing something, to go harvest your Facebook credentials or do something like that. And there's another, whole other set of techniques and ways to do. There's a lot of ways to do cross-site scripting. So things that might happen to you if you get nailed with this, you could cause the victim to change any data that they have access to change, or to perform any function that victim is authorized to do. And this impact varies on what the victim's role is, whether they're a regular user or an admin, and what kind of sensitive data or sensitive actions they can take. So, brainstorm a few possibilities. What if it's a banking site and it's the bill payment interface that's vulnerable to this kind of thing? Yeah.
So it might be implemented. You got an image tag, and the source is actually something where it's going to build a URL to go out to Facebook, and it's got the query strings, and you've got your Facebook authentication, the cookie.
Right, because you're hanging out and you've got Facebook open in another tab or something.
And so
yeah.
you click on this image link, and
Or the image you visit a page that has it on there. So like there was a cool exploit. Is this the one that we linked to?
Gmail one?
The Facebook one. There was a cool Facebook exploit at one point. Their logout would happen was available on gets. So you could make an image that would cause someone to log out of Facebook, and then you take that and you post it to their Facebook wall. So every time you logged into Facebook and went to your wall, you'd get logged out of Facebook.
So there's these other two that are listed here. This Facebook one is actually a way to, or was at the time, to post something on somebody's wall that would, anytime someone would view it, it would automatically add an app to their list of apps that they've subscribed to. So you didn't actually have to go and say, yes, I want this app. It would just magically do it in the background for you.
And then that app could then go harvest stuff using whatever permissions that you didn't know you gave it.
Right. And then this Gmail one still works right now. If you go to that URL, it will log you out of Gmail. There's actually an iframe in that URL that actually goes to logout, which is a GET request. So it's kind of scary that it still works.
Yeah, so what we're going to do is we're going to craft an image link that triggers some kind of site functionality here. And this can also be done in an iframe if a GET request works, as well as an image. But let's pop back over to this. And we're going to do this. So we're going to try to get a gift card for evildoers.com for $100. And I'll give everybody, what do you think, about 8-10 minutes?
Yeah, go for probably 10.
I'll do it at 8 and we'll see where we're at. So this is a case where the view that we're posting to doesn't actually care if it's a get or a post. So you can do some bad things.
Yeah, so you'll need to open up that form in probably a new tab so you can kind of reference it back and forth.
Just wander for a little bit. Not really.
Basically there for reference.
It basically just shows you the input parameters for that form. And then what you want to do is craft a small bit of injection that puts an image into the page that has values for that form in the URL of the image. So you're not actually loading an image. You're just telling the browser, well, go get this thing, and everything will be fine. Trust me. You have an automated solution for this one too. Yeah, I was going to go click this. Okay, cool. Yeah. I see you were trying the exercise. That's a good hint. Mm-hmm. Oh, and we should point that out that this is a place where we're using a previous type of vulnerability to do additional attack, and how you can, get through things and pivot on them and stuff. Mm-hmm. So yeah, we should probably take a couple minutes or take a minute and mention that. Yeah. Oh, yeah, absolutely. I agree. Yeah. That'd be bad. Yeah, I got 2 minutes left. I think I put it up for 8. Yeah.
So one of the things I'm noticing.
Hey. Do you want the?
So people are trying to attack the form instead.
Oh, okay. Yeah. You want this? Sorry.
So one of the things I'm noticing right now, people are trying to attack the form. The form is really there just for reference, and then you want to use the QS parameter on this page to basically do a get to that form. So you're not actually going to attack the form. You're going to use the form as like the third-party site you want to actually invoke, but you're going to invoke it from this page. There's still some questions.
Yeah. You want to do 2 more minutes?
one
Is
is
that
still
still
trying.
there? Oh,
Yeah.
oh, that's a bug.
Yeah. Okay.
Yeah. All right. That's a problem. Sorry about that.
Okay, that's fine. I just wanted to make sure I hadn't missed something.
Yeah, no, that's probably a bug. That's exciting.
Okay.
Yeah. That would be the old pre this set of exercises, like pre-porting path. That's a thing. Hey, Dave. Hey, Dave. JavaScript code is still looking for the old path. Which is the old path? The danger, vulnerable, blah, blah, blah. That's not good. Yeah, I know. Oops. So that I don't... Did you run the automated solution on this before? All right, well... Interesting. Do we... Okay, I guess we had a old... Or he might have an old thing.
That could be.
Yes, okay, that's been 10. Do you want to do a little bit more? Okay, so I hear a lot of chatter that seems like people are getting this one. So in the interest of time, we're going to get to the solution. So what we're going to do is grab URL lib again, build up a URL to this form. So we're going to send it to csurf/gift card with the email that we want to send it to and an amount of $100, because I think $100 sounds like fun. And we build up some JavaScript that's going to create that image element, set the source to the URL that we just created, and set its display to none so that the user doesn't even see it, the victim won't see it at their end, and then append it to the body. So we're combining a cross-site scripting exploit with csurf to be able to pull this off. So this way, the domain on the link is familiar to the user, and it's also possible to embed images on different sites or within an email to accomplish this too. So you could have a nice HTML email that gives people $100 gift cards when they view it, if they happen to be logged in. Yeah.
Is there an advantage to going through this longer version as opposed to ending an image HTML at the end?
Question was, is there an advantage to going through this longer version versus appending the image HTML on? It's a good question.
Mic off. There you go. Okay, so any way you can get the image tag in there is going to work. Right? So the benefit here is that it was really easy and browser agnostic. If you're using, or the site's using jQuery, it's really easy to do really simple, small things so the URL looks a lot smaller. But anything that you can do to execute that JavaScript and get it to actually do what you want it to do would work just fine.
So huzzah, we successfully padded our pockets on the backs of others. Yes?
So I'm actually exploiting different websites.
Yes, if you're trying to exploit a different website, you would have to put the fully qualified domain. So like this example, we're exploiting the website itself to attack itself, but you could put that link, like Mike said, in an email or on your personal website. So they view your blog and they give you a gift card.
Or a message board that would let you post images. We had a fun, it wasn't a csurf thing, but we had a fun issue years back where somebody put a bad link to one of our pages in some Spanish language message board that I had no idea what it was talking about, but it linked to one of our greeting cards. And anytime somebody hit that link, it would throw a traceback. And at that point, I would get an email every time there was a production traceback. So anytime somebody viewed this page, I would get two errors because one from the original message and one from somebody did a reply to it. So it's this fun kind of drive-by side effect thing. All right, now for the sort of what if, imagine a banking site that has a transfer function you can call. Maybe we can use this to route money between people's accounts, and maybe I'd like to enrich myself, and we'll just hide that away, 0 width, 0 height, whatever. So this could be real bad news if you hit somebody with it. So for this next example, we actually just patched a bug in it. So if you have the repo from Git, please do a git pull and then restart the Django app. If you are running off the USB stick, this is a great place to make friends with your neighbor who has the updated stuff from Git. Basically, the validation was left over from a previous version of this exercise, and looks like we missed that until today. So thank you in the back for actually spotting this.
It's totally my fault.
Yeah.
Question?
I'm not quite sure I understand how authentication cookies and sessions play into this. I don't know, pick two sites that I might be authenticated with. Let's say I'm on GitHub's website.
Sure.
Is it not correct that when I'm on GitHub's website, it doesn't have access to my Facebook cookies?
It doesn't.
It doesn't, but you do. So if I somehow embed something into my GitHub README that renders as HTML, that has a link in it that somehow talks to Facebook and does something on Facebook, that will execute as you to Facebook and do whatever the action is.
Right, because your browser will cheerfully your browser will say, oh, I'm making a request to Facebook. Let's see if I've got any cookies that I should send to Facebook. And any Facebook action that you could trigger with that would just happen to you without your knowledge as your browser goes and fetches a thing.
So AJAX calls are not going to work in this context, because those are executed within the context of the current page and with the current cookies that page has, not some other page you might be going to.
Yeah, I believe AJAX calls will not. You can't. But, I mean, the general attack here is that you're not necessarily trying to do AJAX calls. You might actually make an image call or image tag that executes something that the AJAX call would have done, and it would still execute in the context of that particular domain.
Right. So if you know that like a third party has an endpoint listening for some AJAX request, if you can formulate a thing that hits that, then yeah.
I mean, AJAX from the browser side.
Right.
Right.
Yeah. Yeah. So AJAX from the browser side, not so much. Okay. So for the next exercise, once you've pulled the fresh updates from GitHub, we're going to create an innocuous-looking form that's going to post to a vulnerable location, and we're going to do some gift card stuff again. So this is simulating the idea of an attack from a third-party site that controls the form, using something that's enticing, like I want to view photos because viewing pictures of people's cats or small children is a thing that people do on the internet, and that people will want to do. But instead, we're going to use that same vulnerable gift card form to send gift cards to ourselves.
So in the first example, it was able to use the GET request, right? So the site was vulnerable to actually making side effects via GET request. In this example, the site is presumably smarter in checking for posts, so you have to kind of mimic what a form would do. So if you think about those other sites that you would go to and say, yeah, I want to enter the site, you click the button, or yes, it's me, you click the button. And anytime you click that button, that could actually be a form post. And if it's a form post, where does it go? Is it to a third-party site, or is it to the site that you're on, or both?
So in this one, I actually have to go and hack stuff in the thing, right?
Are you up to date?
Yes, I am. Yeah, I just pulled a little bit ago.
You don't have to have the form. You don't need messenger.
Oh, sure.
To GitHub somewhere?
Nah, it's okay. We can do it here. We'll do it live. It'll be fun. Doing it live! Well, there's nothing quite as much fun as like patching the next exercise while people are working on the one right before it. That was pretty cool. Achievement unlocked, I think, if this manages to work out for everybody.
That's the phone that I used.
Yep. So people would say, oh, look, it's a valid certificate. I mean, chase.com, whatever. It's a Jake and Morgan. And he wasn't really Jake and Morgan. He was a malicious hacker who did people's account. Right. So it's like, just to illustrate the point, like SSL, yeah, it's good for transport of the data, but it's not really, doesn't really guarantee anything. So
Right, and like Mike said earlier, like corporations actually override your certificate, so they can validate the outgoing request. So even though you think you're talking to Chase, you might be talking to an endpoint that the company controls, and your machine trusts all of their certs, so it can say it is whoever it wants to be. So there's some other layers of things that happen that your data can be exposed.
yeah, especially if they have some sort of distributed, backends or whatever, which is probably do, like traffic and whatnot.
Yep.
And then you're getting one of those like asterisk certificates, like a block card.
Sure.
And then you can connect to another secure server, and you don't anywhere. So just the front end.
Right.
You to believe otherwise.
Right, and SSL only protects you against a couple of these things.
Right. No, but it's just like one thing in general. That you'd be surprised how common people
Well, I would not be surprised.
think that, oh, it's SSL. Don't worry about it. We're covered. Yes, we're covered.
Yep. We are a little bit under 20 minutes left.
Okay.
So I was thinking we may need to end this one sooner than the other one.
Do that.
We're going to do 9.
9's no exercise, 10's is short exercise.
Right.
Okay.
And then it's wrap up.
Okay.
So I think
Ended. How long has it been?
I didn't start. That was the problem. I didn't start it right when we started this one, so I gave myself an extra 5 minutes. But I think we want to probably rein it in the next minute or so here. Does it seem reasonable, or should we I guess we can get give it to 12:05, and then we'll do 50.
See how people
Yeah.
are doing it.
Yeah. Okay. Show of hands real quick. How's this coming? Show hands up if you got it kind of going. Okay. In the interest of time, I may cut this off in about a minute, just to make sure we get through everything today. If that's cool. Yeah. At least I hope I'm done. We'll find out. Looks good?
I think that looks good.
All right. Okay, so I can just throw this up on the other side here. Yeah. Sure. Want me to go ahead and sufficient time? The time? You think? All right. Okay, so I'm going to go ahead and show the solution that we did. Hopefully that's readable. Font size okay? Let's make it bigger. Bigger! All right. So went into this page. We added a form that's posting to that gift card location. Made the email hidden. Made the amount hidden. Oh, did I actually hide that? No, I didn't. I'm a terrible person. I'm bad at being a bad guy. Do it live, he said. That'd be great, he said. All right, this is actually, I think, my first live coding at PyCon, so feeling good. 9 years of PyCon, my first live code, and it goes goofy. All right, and then a nice enticing submit button that says view photos. So let's save that, and if I've done it correctly, this button, I'm going to see cute kittens and babies and stuff. Oh, but I've just given money to the bad guys. All right. Yeah.
So I'm a little surprised that browsers will do cross-domain posts like that.
Yeah.
And
Yeah.
that's a really good point. Cross-domain posts are most of the time not going to be what you would want to do.
And how do you, as the let's say you're the company that runs the gift card site. How do you protect against this?
So, if you're the company that runs the gift card site, let's talk about how we prevent things. So don't do things on a get. That's bad news, right? Because then Google comes and indexes like your delete link or something and then wipes out your user data. That would be no good. In general, with CSRF mitigation, you're looking at including a unique token in some hidden field, often in concert with a cookie. And that token then gets validated on the server side to make sure the request is legitimate and from on the site. This is what Django does out of the box. You want to avoid putting that token, obviously, in the query string because you don't want to compromise it or have it easily visible or easily captured in your history and stuff. So, like I said, Django does CSRF protection out of the box. So, in general, don't change its built-in settings.
This app, I actually went through and made it bad. So I actually took out the protection that they put in automatically.
There is a CSRF middleware that comes enabled out of the box, and then basically you put a CSRF, CSRF token tag that goes into your form template. It's usually like the first thing that you'll see in the form. So you'll have like the form element, and the first thing after that, somebody will do curly brace, CSRF token, and close the curly braces. And that way, you're good to go, and that form is not going to get CSRF'd.
Yeah, so what Django does is make sure that if you use that when the post comes through, the original form was actually shown on the website. So it uses that token and a cookie that it sets with the middleware to make sure that it's the same person and they got it from the right domain. So you can't actually put a form on someone else's domain and enable that, right? So the cookie is only for your domain and not for this third-party domain.
Right. You want to be really, really careful about deactivating it. We use the CSRF exempt decorator to open ourselves up here. So be really cautious. There are times when you might have to do this, but you want to be real clear that you know what you're doing and that it's not going to lead you into trouble. You also want to be careful about building APIs and stuff. So you want to make sure you got OAuth wired up when you're building like a nice Tasty Pie API for your Django app. Yeah, question?
So back to why do the browsers allow this? Why in the world would you allow a hidden form to be submitted or an image of size 0 to be pulled?
That's a really good question.
Yeah, so the question was, why would you allow hidden inputs to be submitted? Why would you allow images of size 0 to be added to the page?
That's a really good question for like Chrome or Firefox because I can't think of a legitimate user I would need to actually have the browser on one domain have a secret or hidden form that posts to another domain.
Well, tracking pixels, right? You're
typically not posting for tracking pixels.
You're not posting,
so
but you're doing a get, right?
I can see the gets. I don't see the post utility. Was there a question in the back?
No, that was going to be the same thing.
Okay, cool. All right. We got about 10 minutes left, so we're going to kind of breeze through here. So vulnerability number 9 is using known vulnerable components. So this is obviously kind of pretty self-explanatory. So your libraries, your frameworks, and other modules are almost always run with full privilege of the app server. And it's really hard to stay up to date on everything. And do you know even all of the dependencies you have and their versions and the dependencies of those dependencies? So any component with a known problem could be identified and exploited by some automated tool, at least to find them. And then the attack can be customized. So attackers typically identifying some weak component through scanning or manual analysis. Maybe they see, from your headers, you're running an old version of Apache, and I can do some bad stuff to that, or an old version of Django or something. Then they tweak the exploit as needed for that. And this is harder to do the deeper into your application stack the component is. Obviously, the closer it is to the outside, the easier it is to find it and know about it. So the full range of weaknesses are possible here. The impact could be really minimal, or it could be a complete host takeover, game over, data compromise, all kinds of bad stuff. So OWASP suggests that you not use components you don't write yourself, which is, as they admit, also very unrealistic, because you also don't want to write your own crypto, right? So security is not a destination, it's a journey, and sometimes these forces are at odds with one another. But what you really want to do is you want to make sure that components you do use are kept up to date. And you want to identify everything that you run and all of its dependencies and all the versions that you have out there, and then monitor them for updates and understand what their security situation is. Django specifically, when Jacobian on Twitter says there's new security releases for Django, as there have been over the past couple months, upgrade. It's important. This is like, Rails having its thing and everybody freaking out with their hair on fire and upgrading. You need to upgrade when somebody has a security release. Any questions on that? All right, cool. Easy peasy. Last set of exercises, unvalidated redirects and forwards. So this is where an attacker is going to try to trick you into visiting a URL that redirects or forwards the request to something else without validating where it's going. And the users are prone to click on these links because it's a legitimate site, and it seems like I want to go there. So unfortunately, being redirected through somewhere malicious means that they could install malware. They could be subject to phishing or other information disclosure attacks, or they could bypass access controls and get into something they're not supposed to. So we're going to do 2 quick exercises. In the first one, we're going to use a redirection URL to redirect to whatever your favorite external domain is. So a lot of times you might have something on your site that needs to redirect you, like when you're going from HTTPS back to HTTP, and you want to avoid having your browser alarm you that, like, hey, we got redirected to a non-secure location, what gives? So our vulnerable code base has one of these awesome vulnerable redirect things, so we'll attack that and make it go somewhere. And this actually does the redirect inside itself, so we have to go read what this link is. That's my big hint for this exercise. This will do, I think, 2 minutes.
Yeah.
That should be pretty quick, I hope. Yeah, we should have. All right, who has a favorite evil third-party domain that they're redirecting to?
Google.
Ooh. Reader! I've been really entertained watching the anguish as people around me react to that news. Like, somebody will be like skimming through Twitter on their phone and suddenly like, what do you mean Reader's shutting down? And, huge sorrow. Then somebody else sees it 20 minutes later. It's been sad, but also amusing. All right, so this could be pretty straightforward. We could go to like example.com, and it sends us off there. All right, so that's bad news. We shouldn't do that. Everybody pretty much got how that works? Pretty easy.
Question?
So you could make up some page that's a lookalike or some kind of thing that impersonates the legitimate site. And if you've got a redirect for that, then your end user is going to see, legitimatesite.com. Great, I totally want to click that. And maybe it's even in a button or something. And the redirection then takes you to something that looks like where they think they want to go, but is busy installing malware on them or something when they land there.
But you still would see the URL, like the word forward.
You would once you land, yeah.
A lot of people at that point, though, they're not paying attention.
Yeah.
They thought they went to Facebook, and now it looks like Facebook, and they're asking me for my password, so I should just type in my password.
Yeah, maybe it's a typo domain, right? So Facebook or something like that.
So don't do redirects via URL.
Yeah, if you can help it, don't do that. That can be
Or at
bad.
least whitelist them or
Yeah.
have some kind of protection for the user.
Yeah. So we're going to do a real similar thing with forwards. And this is where, under the hood, rather than going to somewhere else, we're going to reroute the request to some different callable inside. And we have sort of the same kind of thing, which we're going to use to get back into that super secret admin area. Oh no, we don't have a happy function we can go to.
A happy function.
We don't have a happy location. Where could we forward to instead? Oh, admin? Let's try that. Oh no, I hope no bad guys get in here.
It's too late.
Yep. All right, so we got about 4 minutes, so let's kind of buzz through and get you guys to lunch. So don't use redirects and forwards if you don't have to. If you do have to do that, don't involve user-supplied data in building that redirect location. And you want to ensure that the supplied value for that redirect location is valid and it's something that's authorized for the user. Django recently released a thing called isSafeURL in Django Utils HTTP. You can use that to check redirect URLs, and it's used by Django Contrib Auth internally. And basically what it's doing is it's verifying that the link is to something that's on that local domain. So if you're on example.com, it would only, make sure that all of those redirects would be restricted to example.com. You might also want to consider wrapping isSafeURL if you have to allow redirection to other off-domain URLs. Like maybe you have a whole payment server URL that's separate from your main site. You've got a specially secured environment to comply with PCI standards or something. The default implementation of isSafeURL is only checking the entire domain. So if you've got checkout.mysite.com, you'd want to wrap that and make sure it's going to be okay. All right, any questions about that? All right, cool deal. So now who here has vulnerable web applications? And who needs to pay attention? All right, great. So a few parting thoughts. The first thing is, whenever you're writing web applications, you always want to be thinking like the bad guy. Thinking about, is there a way to do something harmful with the project that I'm working on or the feature that I'm trying to deliver under pressure for my business? But you always got to think like that evil person. And people will accuse you of being paranoid. Like, oh, people don't really do that, do they? And like, yes, they do. You have to be paranoid about it. Think about everything like a bad guy. Don't stop at 10. These are only the top 10 vulnerabilities. There's a whole lot more bad things that can happen to you. So please, go do some more research, see what else is out there, and use those resources to improve the security of your systems. Yeah. You have to be prepared to keep up with the constant change that's out there. New vulnerabilities are being discovered all the time. There are security releases coming out all the time. You have to be vigilant all the time. But finally, you have to think positive, right? You can't just be defeated and be like, I can't do this, it's too hard. Really think, yeah, you know what? If I put a sane process around this, if I pay attention, if I and my other fellow developers are educated and we do things the right way, we can systematically improve our security stance, improve our situation to protect your users, protect your data, protect your organization, your business. So, just wanted to recap announcements really quickly. Lunch is in Exhibit Hall D, so that's where you want to go for delectable delights today. Please send feedback to the tutorial feedback link. There's a SurveyMonkey survey, that shortened URL. It's really important that we hear feedback from everybody about how you thought the tutorial went, as it does influence how tutorials work going forward for PyCon. And finally, volunteering is really important. You can go out to those bit.ly URLs and find out about what opportunities are available and what they need help with today or over the course of the conference. I really encourage volunteering. It's a lot of fun. There are links to stuff. You can contact us if you want to ask questions later or talk to us right after here. And I'll update the GitHub repo with a link to the slides this afternoon when we post the slides. So I really want to thank everybody for coming. Hope you had a good time and learned a lot. So.